Bismillahirrahmanirrahim. Today is our lab 5 of timers and interrupts of micro and embedded system. Now our task 1 is to show the counting on the LCD by using the interface of LCD with the timers and counters. Here you see that I have written the code for the task 1, and here I am representing the main file in which I have included the library of my lcd11.h that I have created previously, and in previous lab the same library I have used here. After this, you see that my main function in which I have declared the port B as an output and port C also as an output. After that, I am using the array of size 11 type character, and then I am calling the function of LCD initialization that I have made in the library of LCD. Then I am calling the LCD string function in which I am return counter equals to. After that, I am giving the value of timer counter TCNT 0 register to 0x00 to initialize the value, and then I am giving the value of TCCR0 A 0x00 and TCCR0 B 0x01 to set the timer and counters of normal and normal mode, and then 0x01 for the prescaling. And then I am defining the condition of while in which timer interrupt flag register and with the one less than timer overflow register overflow. This is going to check when the timer overflow is equals to 0, then I am going to implement this while condition, and if the timer overflow is not equals to 0, then the else condition will perform. Then you see that here in the while condition I am calling the function of it0a tcnt00 and array and 10, and an lcd string function calling the and passing the value of array in this, and then lcd command function is calling, and if the while condition is not true, then my this condition will occur in which tccr0b again goes to 00 and timer interrupt flag register equals to 1 less than a timer overflow. This statement is always calls to reinitialize the timer interrupt flag register. I am giving the value of 1 in the timer overflow to reinitialize the timer interrupt flag register. You have to remember this. This is the main point. Now I am going to show you the Proteus simulation of this task. You see that I have interfaced the LCD with the Atmega microcontroller, and ports are connected as the LCD. Now I am going to place the hex file of this code here. You see that I have already placed the hex file of this code. Now I am going to show you the counter on the LCD. See that counter equals to 6 starts, and then the counting starts. So this is our lab 1, lab 5 task 1, in which I have to count by using the interrupts. Now our task 2 of lab 5 timer and counter is lab 6 timer and counter is to count the number of interrupts by using the button. So for this I am representing you the main file of my code, in which I have again called the lcd11.h library that I have already made, and I will also show you the library of LCD. After this, in the main function I am calling the ddrd port 6 as an input and port C as an output and port B also as an output. After this, I am using the timer counter register TCCR1A 0 and TCCR1B going to value of 0x0A for the falling edge. I am going to operate this function on the falling edge. After this, I am going to set the mode. For this, I'm going to send the value of on 0 or C1A of 1 for the CTC mode, because I'm going to operate now it on CTC mode, and then I have used the variable C of integer type and store the value in 0, and then I have used the array of size 10 of character type. After this, I'm going to start my LCD. For this, I have called the LCD initialization function, and then finally in the while loop I am going to LCD command function and call the LCD string function to write the counting on the LCD. After this, I have again called the while condition in which the timer interrupt flag register 1 and with the 1 less than OCF1A equals to 0 output compare flag register. In the CTC mode, we have the output compare flag register, and in this I have called the condition when the timer interrupt flag register and with the 0 output compare flag register equals to 0, then our timer interrupt flag register 1 will go to 1 on the out compare flag register, and then C will increment with the C plus 1. Means that whenever the interrupt will come on the, then our counting will increment by 1. Means when I am going to on and off the button, my counting will increment. So this is the code, and now I'm going to show you the library that I have made for the LCD. You see that here I have called the RSPB0 RW write and enable and LCD data on port on for this. After this I have called the made the LCD initialization function in which I am going to on and off my LCD, and then LCD command function to enable the RS RW and enable and on off the LCD. After this I have called the function LCD data to write anything on the LCD, and after this I have the LCD string function to write anything on the LCD. So now I'm going to show you the Proteus simulation of this task. You see that here I have made the code for this task in which I have used the ATmega 2560 microcontroller with LCD interfacing. Now I'm going to here I'm going to place the text file hex file of this code on the Proteus. Here I have placed the hex file. Now I'm going to simulate this, and then by pushing the button I'm going to use the counting start. Now I'm going to push the button on and off to implement my counting. See that now counting equals to 1, and after this now counting equals to 2, and after this again I'm pushing the button, now counting equals to 3. So this is our task 2 of timer and counter lab 6.2. Every time I am going to on and off the button, my counting will increment. So basically I am counting the interrupt. Every time the interrupt comes, my counting increments. So this is our task 2. Now our task 3 of lab 6 timer and counter is to make a digital clock using the timer counter registers. For this I have again called the LCD11 library that I have already created. After this I have called another function to delay, and then I have in the main function you see that I have used the port CS and output, port BS and output, and then I have initialized 3 character arrays of size 10 for the hour, minutes and seconds, and after this I have used 3 variables hour, minute and second. And in the while condition now I have called the LCD initialization function string function to operate my LCD. And after this, to make a digital clock I am going to use 3 nested loops. The most external one is for the hour, which will begin from 0 and goes up to 24 because there are 24 hours, and then the next nest loop is for the minutes and it will go from 0 to 60 minutes, and then the innermost loop is for the seconds, which will again go from 0 to 60. And in this manner our clock will operate. And after this I have called the LCD string function in which I have called the hours, minutes and seconds with the some delay because I am making a clock, so this is going to operate for some delay clock. And then finally I have called the to delay function in which you see that I have use the timer counter interrupt high register goes to value 0x61 for the 1 millisecond delay, and timer counter NT1L register 0x80, and then in the TCCR1A timer counter register to operate in a normal mode, and TCR1B going to 0x01 for no prescaler because I am going to use it as it is no prescaler. And in the end I am going to again while condition that I have previously also used in which the timer interrupt flag register and with the timer overflow register equals to 0. If this condition is true, then I am going to stop my timer, and for this I am going to show the value of TCR1B00 and timer interrupt flag register timer 1 on the timer overflow, because to clear this timer flag register we have also given the value of 1 in it, and in this manner our timer will stop. Now here is the simulation of our clock task, in which I have interfaced the LCD with the Arduino microcontroller 2560. Now I'm going to upload the hex file of my code here. This is the hex file. I have placed the hex file. Now I'm going to simulate this, and the LCD starts and clock starts. Now you see that our task of lab 6 by using timer and counter, in which we have to make a digital clock, is completed, and now our lab 6 tasks are completed. हमारा लैब नंबर 5 का टास्क है, जिसमें हमने टाइमर काउंटर के थ्रू क्लॉक बनानी थी। तो ये आप देख सकते हैं हमारी क्लॉक है, तो चल रही है, टाइम हो रहा है 1 मिनट 1 मिनट एंड 50 सेकेंड्स। तो ये हमारा लैब कंप्लीट हो गया, टास्क कंप्लीट हो गया।